everyone, how are you all? So today I am back again with another playlist on the topic of vector and 3D geometry. So you must be wondering, what about the playlist of matrix and determinant? So the matrix and determinant playlist, that is a video for JEE advanced previous year question on the topic of matrix and determinant, will definitely come very soon on this particular channel. So do subscribe the channel and press the bell icon to never miss out the content. So today we will start with the topic of vectors and 3D geometry. Now you must be wondering, why did I start with this particular chapter? Now after studying determinant, the best example, the best application to study the use case of determinant will be the chapter of vectors and 3D geometry. Now in 3D geometry and vectors, there will be lots of cases and situations where you have to apply the particular principle of determinants. So I started with the topic of vectors and 3D geometry to take up the use case, and also the vectors and 3D geometry is very important topic for the examination purpose. Even if you consider JEE mains and JEE advanced previous year questions, you will see there are lots of questions coming up from only from this particular chapter. So this is very easy chapter and a scoring chapter as well for your JEE mains, JEE advanced, CBSE class 12 board examination, and even if you consider the any other state government examination or engineering level or WBJ examination or any other examination in particular. So today we will start with the topic of vectors, and then we move on to study the further topics of vectors, and simultaneously we move on to the topic of 3D geometry. So stay with me and stay connected with this particular playlist. So my name is Sirsha and I am currently a BTech student at IIT Kharagpur. So let's get started. So in today's goal, we'll be basically taking the good understanding of this topic of vectors and its understanding, and then we move on to study about the laws of addition, that is basically the law of triangular law of addition, polygon law of addition, and parallelogram law of addition. So with this, and I will move on to study about the properties and rules and its basic questions. So let's get started with the what is vectors. So you must be wondering, why do we need the use case of vectors? Now what is this particular word vector stands for? So if I say a vector, for example, if I say what is a scalar, you must be understanding a scalar is basically a physical quantity which represent a measure of any particular quantity. So you must be also thinking, then why do we need vectors? In many cases, for example, its use case is actually in physics. Its use is in physics. But why do we need the chapter? And in physics, its uses is applied. So there will be lots of cases in physics where you have to apply vectors. Now before proceeding with vectors, and after you studying with vectors, you will see in many cases of theoretical physics, you also apply the concept of vector calculus. So we need that, for that particular purpose, we need the topic of vectors. So let us get started and write some basic definition regarding vectors. So vector is a physical quantity. It is a physical quantity, okay, which is described by direction as well as magnitude. Okay, so any such physical quantity which is actually described by its magnitude as well as direction associated with it, is such quantity are known as vector quantities. So why do we need the vector quantities? So basically it relates with this situation in physical situation. So let us relate of in a physical situation, that is a building, and on the top of a building a boy is standing and playing with a ball. And for example, if the boy throws the ball in such a direction, in this particular direction, and in such case the ball will follow a particular kind of trajectory which is a parabolic path under the force of gravitation, and this particular trajectory is followed by the ball. So if we consider at any particular point, if we try to represent its speed as well as direction, we need another important quantity that is known as velocity. So velocity is basically a vector quantity which is represented by magnitude, which is equal to the magnitude of speed, and the direction which is associated with the direction which is given by tangential to at any particular point. Any particular point and tangent to that particular point gives the direction of that particular vector quantity, that is known as a velocity. So if I say there is a boy who throws a ball with a velocity v vector, so if a boy throws with a ball with a velocity of v vector, then that particular ball actually follows this particular trajectory. Now in order to find the trajectory and the equation of trajectory and various calculations regarding to it, we need such quantities which are actually known as vector quantities. So in this particular lecture, we are going to be studying about why do we need vector quantities, and what is basically the significance of the vector quantities and how it is represented. So for the very particular thing, I am very clear that vector quantities are basically physical quantities. By physical quantity, I mean to say these particular quantities are actually used to represent any particular physical sense, that is having its magnitude as well as direction associated with it. Now, to it I want to add some important thing, that it always obeys, and it obeys commutative law of addition. Now, by addition I mean to say vector addition. So by saying any physical quantity which has direction as well as magnitude is not enough to define a vector quantity. For example, you might also know in case of electric current, you will see that the current, for example, there is a current which is I1 in this particular branch, and there is another current which is I2 in this particular branch. Now, from this particular situation we see the electric current also has a magnitude as well as direction associated with it, but it doesn't follows the vector's laws of addition. Hence, electric current is not a vector quantity. So from here it is not enough to say that any such physical quantity which has direction as well as magnitude is not a vector quantity. Simultaneously, it is also equally necessary to definitely explain that such vectors are physical quantities which has direction, magnitude, and also obeys the commutative law of vector addition. Then such particular quantities are actually known as vectors. So I hope this particular discussion was clear. So vectors are actually represented by small letters, represented as this particular small letters are actually representation of vectors with a small arrow on its head. Now, this particular quantity actually represents a vector quantity which has, and this particular vector quantity can also be written like this, that it has a magnitude, that is the magnitude of A, and it is denoted by that giving a bracket across it in such way, and also writing its unit vector in this particular direction, which actually represent the direction, and this particular thing represent the magnitude, and this as a whole is actually the representation of a vector. Okay, now this is actually known as unit vector, and which is denoted by this particular thing which is also known as a cap. Okay, this is actually called as a cap. So a cap actually represent the unit vector which is used for direction, So I hope the representation of vector is basically very clear. So if I talk about, there is a particular line segment, which is represented by the points P and Q, and this particular line segment is in the direction the direction goes from P to Q, then such vectors, such particular thing can also be represented as vector. Now if I see this particular thing as a vector, which is vector A, now this thing I can also write it as the vector A is also equal to magnitude of the PQ line segment, multiplied by the direction in which it goes. Now the direction can also be written as a cap. Now this particular a cap direction is actually given by the points from which it is starting to the point which it is going, and this cap. Okay, so this particular vector can also be represented by the direction of a cap. Now a cap can also be represented as PQ cap. So this particular PQ can be a vector, and this vector is actually called the A vector, which is equal to PQ cap modulus. That is a modulus, that means the magnitude of this particular vector multiplied by the direction in which this direction is associated. So this particular thing makes the complete representation of a vector. That is, whenever we try to represent any vector by a straight line, for example, there is a straight line that is PQ, this particular PQ vector is actually represented as the length of this particular line segment. That is, if I say the length is D, so I can write it as a D, and it is the direction of P to Q, so I can write it as PQ cap. I hope this particular discussion is actually clear. So vectors are generally represented by small letters, and they are actually represented as with the magnitude multiplied with the direction associated with it. So with this I come to the important conclusion of the representation of matrix. Now there are other important terms which I wanted to mention about vectors. Now the length of the vector, basically if I say any particular line segment which is actually a vector quantity, the length of the vector actually represent the length of this particular represent the magnitude. The length of this vector actually represent the magnitude. And similarly, if I say a support, and the sense is basically mean to say the point from when the vector is originated, and the sense is basically talks about the direction in which the vector actually goes. So this particular important nomenclature will come very handy when you try to solve the important questions. So with this, let us start with the topic of types of vectors. I hope this particular discussion was clear on the representation of vector. So let us start and study about the different types of vectors. Now moving on with further the types of vectors. Now the very first type of vector that we will study is basically equal vector. Now what is meant by equal vector? Now if I say there are two vectors and these two vectors are equal, that means they are equal in magnitude, and direction as well. So two vectors are set, for example two vectors, there are a vector and b vector, are said to be equal and are written as a vector equal to b vector if they have the same length, that means the same magnitude, and they are same support, and they have the same support, that means they are parallel, or they have same support, that is a particular starting from the same particular point, maybe starting with the same particular point. So for example if I say there is a vector which is a vector and this particular vector which is a v vector which also having a starting point on the same which may also have the starting point as the same of this particular thing, that is if I represent as OA, so I can say that the vector A actually starts with O. So this another vector which vector B are said to be equal if this particular vector has the same magnitude and the direction, that means it may have the same starting point or it may be parallel to this particular vector, that is in the direction of this particular vector, and such vector is represented as B vector. Then I can say that both the vectors have the same magnitude, as well as both the vectors have same direction. In such case I can say that both the vectors are equal vectors. So I hope this discussion was clear, and let us move on to the another type of vector that is known as null vector. Now null vector is basically a vector which is having a magnitude of 0 and infinite direction, whose initial, also I can say initial point is same as the final point. So such vector whose magnitude, then such vector will obviously have a magnitude which is equal to 0. And if I say the initial point is equal to the final point, then I can have infinitely many directions of this particular vectors. So such vectors which have a magnitude 0 and infinitely many directions are represented by null vector, and this is represented by 0 vector. Okay, this is represented by 0 vector. So such vectors are known as null vector. Now let us move on to another important type of vector, that is basically unit vector. Now we have already seen the use case of unit vector is basically to represent direction, of any particular vector of a vector. And represent what? Now represent direction of a vector. Okay, represent direction of a vector. This is very important thing. And how do we get to the unit vector is an important discussion that we will take up in the upcoming lecture as well. So a unit vector is such vector whose magnitude is equal to 1. A such vector whose magnitude is equal to 1, then such vectors are known as unit vectors, and they have the direction associated with the particular vector. So such vectors are actually used to represent the direction of a vector, and they are actually represented by like this, saying a cap, or for example there is another unit vector which is in the direction of b vector, this is represented as b cap. So if I say there is a vector of a which is in the direction of, and which has a magnitude of d and is in a direction in this particular fashion, okay, from p into q, okay, and in such case I can represent a unit vector as pq vector divided by pq vector modulus. PQ vector divided by PQ vector modulus, then in such case we will get the PQ vector, we can get the unit vector that is known as A. So what I say, if A is the vector which represents PQ, then PQ can also be written as modulus of PQ multiplied by A cap. So this particular discussion was actually the discussion when I took up the discussion of the representation of vector. So I hope this particular explanation was clear. So with this, let us move on to the fourth important type of vector, that is known as a like and unlike vector. So what is actually meant by like vector and unlike vector? So like vectors are vectors are said to be like if they have the same sense of direction, unlike or when they have opposite sense of direction, unlike when they have opposite sense of direction. So like vectors have same kind of direction. Okay, so like vectors are said to be two vectors. For example, if I have vectors a and vector b, then they are said to be like vector if they have the same sense of direction, if and only if same sense of direction. So such vectors may not be equal in magnitude, but they have the same sense of direction, and unlike when they are opposite, and unlike vectors when they have opposite sense of direction. So two vectors, for example, there is a vector which is represented by a vector and b vector is another vector which is in the direction of a vector, then such vectors are known as like vectors. And if there is a vector a and the b vector is in the opposite direction to that particular vector which is a, then in such case we say it is an unlike vector. It is an unlike, and in this case I say it is a like vector. So I hope this particular discussion was clear, and with this let us move on to the fifth type, that is basically co-initial vector. Co-initial vectors. So two vectors are said to be co-initial vectors if they have same starting point. If they have same starting point. Okay, if two vectors have the same starting point, then such two vectors are known as co-initial vectors. In this case, the vector A and vector B have both at the same starting point, that is a point O. Similarly, we study about coplanar vectors. Coplanar vectors. So vectors which lies on same plane are known as coplanar vector, are always on the same plane, then such vectors are known as coplanar vector. Now by plane I mean to say, for example, there is a plane, and plane can be represented can be imagined as a paper, as a sheet of paper. So if in a sheet of paper we have vectors which are riding the same sheet of vectors, then such vectors are known as coplanar vectors. So any two vectors are always coplanar, but if in the three vectors are present and we say the three vectors are coplanar if and only if the scalar trivial product is 0. Now scalar trivial product is basically a concept that I will start up once I cover up the topic of scalar product, dot product, scalar product and vector product, and after that we move on to scalar trivial product and vector trivial product. Okay, so the coplanar vectors are vectors which lies on the same plane. So with this let us move on to the seventh particular type of vector, that is basically known as coterminous vector. So similar coterminous vector, similar to the concept of co-initial vectors, two vectors are said to be coterminous if they have same final point. Then such vectors are said to be coterminous vector. For example, there is a vector A and vector B which both terminates at any particular point which is known as D. Then in such case these two vectors are known as coterminous vectors. Okay, so by this we come to the end of the types of vectors. Now another important types of vectors that I wanted to discuss basically is localized and free vectors. Now in mathematics we don't need to be very much important about the types of these particular vectors. Now basically localized vectors and free vectors, it comes from the concept of physics. Now localized vectors are such vectors which changes when moved about in a plane. Similarly, free vectors are basically free to move and it do not get changes and it doesn't change okay, and it doesn't change on moving, okay. So localized vector, if I take example of a moment of inertia, for example there is a particular body whose moment of inertia about this particular axis is given by this vector which is actually moment of inertia is not a vector quantity, but if I represent it a moment of inertia by a vector which is I vector, actually it is a tensor quantities. Okay, so if I say the moment of inertia, or for example let us not talk about moment of inertia, if I talk about angular momentum or angular acceleration about this particular axis, okay. So if I talk about the angular velocity or angular acceleration about this particular axis of this particular body when it is performing a rotational motion, then such vectors, if I take this particular vector, if this omega vector or alpha vector is taken and moved to any particular axis, for example this axis, the value will get changed. So such vector is actually localized vector. And similarly free vector, in mathematics we actually talk about free vectors only in the most of cases. So for example a vector which is actually a vector is represented like this by an OA arrow, and this particular vector can be moved about, for example, if I take this particular vector and I move about in any particular plane, then the value of this vector doesn't changes. The value of the vector doesn't changes. That means the magnitude of the vector doesn't changes along any particular direction. Whenever we are talking about rotational physics or rotational body, and then the values of these particular vectors actually change along any particular direction or any axis. So this particular concept is actually of localized vector, and if I can move the vector freely about in the plane so that the vector value doesn't changes and remains the same, then such vectors are actually called free vectors. In mathematics we will discuss and we will study only about free vectors. Okay. So with this I come to the end of types of vectors, and let us start about another important topic of algebra of vectors. So by algebra I mean to perform the simple rules, that is addition of vectors, subtraction of vectors, multiplication of vectors by scalar or by vectors. This particular things actually is meant in the algebra of vectors. So let us start with the addition of vectors. Now before starting on the addition of vectors, I wanted to make it very clear. Now vectors addition is very specific to particular laws. Now vector law addition follows three specific laws, that is the triangular law of vector addition, and which is, if it is incorporated to further details, then it becomes the parallelogram law of vector addition, and of its generalized case becomes basically the polygon law of vector addition. So let us cover everything in detail. So with this I start with the triangular law of addition. So the triangular law of vector addition says that, for example, you have a vector, the vector A vector and B vector are there, and if I wanted to write actually the summation of these particular vectors, then I can write it as, if there is a vector and another vector B is given over here. So for example, the B vector is given, and let us represent the endpoints by letters, that is OA, and this particular thing as B and C. So if we want to add these two vectors A and B, and if these two vectors are free vectors, then I can add these vectors by taking the law, as the law says, if you put the B, if you join the tail of another vector with the head of first vector, if you join the tail of the second vector, that is, for example, the B vector tail is given like this. If you join the tail of the vector with the head of the first vector, if you join the tail of the second vector with the head of the first vector, and then you finally join the endpoint, then you finally, in this final figure, if you join the tail of the first vector with the head of the with the second vector, then you actually get the quantity which is represented as A vector plus B vector. So again I represent my statement that if you have a vector which is represented as A vector and B vector, if you take this B vector and you do one more important thing, that is if you take the tail of the second vector and represent and join it with the head of the first vector, and in doing so the figure which is left out, and in that particular figure which is left out, if you take the points which is the tail of the vector, and from the tail of the first vector to the head of the second vector, if you draw a vector representing the direction towards the tail towards the head of the second vector, then you end up getting the result which is actually known as A plus B vector. So this particular discussion was very clear. So with the triangular law of vector addition, if this particular thing is clear, and in this particular situation we actually say about the terms of the angle between the two vectors. Now angle between two vectors is another important discussion that I will take up when I will talk about the topic of dot products and scalar, that is a scalar product and the vector products. So before if I wanted to know what is the angle between two vectors, then the angle between two vectors is actually formed by joining the tail of both the vectors, or by joining the head of both the vectors, and in doing so the angle which is formed by the two vectors is actually becomes the angle between the two vectors. So my words are very specific, that I said when you join the two tail of vectors or when you join the two head of a vector, then the angle corresponding to that actually gives the angle of the vector. So from here if you see that this particular quantity is theta, that means the angle between A vector and B vector, and if I see this particular term as phi, then I can say the angle between A vector and B vector is basically theta, and I can say the angle between A plus B vector and the A vector is basically phi. So with this I will have another important result which I will write in the coming page, and so with that let us move on to and study about the second law, that is the parallelogram law of vector addition. Now this law is very handy and is most important. So the parallelogram law Okay, so the parallelogram law says the same thing that the triangular law says, but in that particular situation, if we represent in terms of if we change the triangle and we represent in terms of parallelogram, the result remains the same. So what if I take a vector, that is a vector is given, and do one more important transform thing, that is you take the vector that is a b vector and join the tail of the vector with the tail of, join the tail of the vector that is the b vector with the tail of this particular vector that is a vector. Now if you join both the vectors such that they become co-initial vectors, now these are free vectors. We are always talking about free vectors, so these they have no problem in moving around in the space. So if these two vectors are taken in such a fashion that the tails are connected, in that particular situation I can complete a parallelogram related to it. So if I complete this particular parallelogram and I make a vector which is pointing in this particular fashion such that this parallelogram takes up the value of this length of the diagonal of this particular parallelogram and in this direction which is specific towards this particular arrow, so this particular direction, then I can say that such parallelogram, the diagonal of such parallelogram gives the result of what is known as the addition of vector. So I can write it as a vector plus b vector. So I hope this discussion was very clear. Okay, so this particular also comes from actually from the triangle law. So we know that in parallelogram the opposite sides of parallelogram are equal. So if I can say this particular side is same as this particular side and they are also parallel in direction, so this particular, so if I represent the parallelogram by O and this particular point as A, this particular point as B and this particular point as C, I can also write, I can from here I can see that OC vector is basically V vector. So from here I can also write one important thing with the concept of parallelogram, that opposite sides of parallelogram parallel and are equal in magnitude. With that I can write the AB vector, the A to B vector is basically equal to B vector. Now if I have a vector such that another vector such that the tail of vector is joining the head of the vector, and in doing so the resultant vector which can be formed by joining the tail of the first vector with the head of the second vector, then we get the result from the triangular law of addition, that is basically addition of two vectors. So similar to that, this particular parallelogram law of addition actually says that if you have form a parallelogram with the corresponding two vectors, then the diagonal to that particular vector actually represent the quantity which is known as the addition of vectors. Okay, so with that, another generalized condition that is known as the polygon law of vector addition. Polygon law of addition. Okay, polygon law of addition. So with this, if I generalize the result such that there is an n number of vectors, there are n number of vectors in this particular plane vectors, and whenever we are talking about addition of vectors, the two vectors can be added when they are actually in a plane. Now the concept of n number of vectors comes to the concept of the plane. Why? Now we already know that when two vectors are present, there can be any one plane which contain that particular two vectors. There always exists a plane which contain two vectors. That means the two vectors if present, and two vectors are always coplanar vectors. But if I talk about there are n number of vectors and they are not coplanar vectors, then such vectors cannot be added. Actually they can be added, but that particular vectors actually comes in particular fashion where you have to take care of the planes of the vectors. So if I say there are n number of vectors, which are lying in the same particular plane, or if not, they are also not lying in the same particular plane, then we get the resultant in different planes. That is another important thing also we discuss about in numerous cases. So if I say there are n number of vectors such that and we take, what do? We join the particular vectors in such fashion that the tail of the vector is joined to the head of the vector. The tail of the vector is actually joined with the head of the vectors. The tail of the vector is joined with the head of the vector. The tail of the vector is joined with the head of the vector. The tail of the vectors is joined with the head of the vectors. And in such fashion, if I go on and make the n number of vectors is completed, then the final vector, if I join this particular final vector with the, and if I join this final vector with the head of this particular vector to the tail of the another vector, then we actually get the quantity which is known as a vector plus b vector plus c vector, and so on to all the n vectors are added. And in this particular fashion, all the n vectors are added. So if I generalize the result for in a triangle, I can say that this is, if there is a two vectors which are present like this, and if I join this particular thing, that is the head of this particular with the tail of this vector, then I get the result which is actually known as the addition of this particular vector. Okay, now in this case the direction is this particular fashion, and if I join all this direction and I add up, we get the vector which is equal to the null vector. So I get the result which is equal to null vector. So in this case, if I change the direction of this particular vector, then I get the result which is actually known as this particular final vector is actually the resultant of this n minus 1 vectors. So if I say, because what we can see, if these n vectors are represented as a vector, a1 vector plus a2 vector plus a3 vector and so on up to an vector is equal to null vector. So if I take this particular vector in this particular fashion, and this is actually known as negative of an vector, and negative of vector actually means the direction is opposite. So whenever we are multiplying a vector with a negative quantity, that simply implies the magnitude of the vector doesn't changes, but the direction of the vector changes by 180 degree. The direction of the vector changes by 180 degree. I will write it. The direction change by 180 degree. The direction change by 180 degree. So if I multiply a vector with a negative quantity, that simply implies the direction gets changed by 90 degree, by 180 degree. So in this case, if I change the direction of this an vector by 180 degree and I represent this an vector, then the an vector will basically, this negation of n vector will basically represent the summation of n minus 1 vectors. Okay. So I hope this particular results come handy when you have multiple numbers of vectors and you actually have to calculate. So keep in general mind any particular closed figure which is connected in such fashion that the tail of the vector joins the head of the vectors, the tail of the vector joins the head of the vector. In this particular case situation, if I represent this vector as a vector, this b vector, this is c vector, this is d vector, and this is e vector. So if I sum of all these vectors, that is sum of all the individual vectors, if I sum of all these vectors, okay, if I sum up all these vectors, that is a vector plus b vector plus c vector plus d vector plus e vector, then I will get the result which is equal to the null vector. So I hope this particular result is important in terms of calculation of n number of vectors. Okay, so with this, let us talk about another important result on vectors addition. That is the magnitude of vector addition, and in which direction does the magnitude, the resultant, that is the addition of the vector, lies. So if you see from the parallelogram, if I say that this particular vector is a vector and another vector which is b vector over here, so the angle between the two vectors is actually given as theta. Then if I complete this particular parallelogram, now this particular result I will also take up when I will be talking about dot product. Okay. So don't worry if you don't understand the explanation right now. So this particular diagonal will obviously represent the a plus b vector. As I said, from the parallelogram law of vector addition, if I represent these two vectors such that the tails are joined, and if I represent the diagonal, if I represent it and I take it and represent the diagonal vector, then this vector will be definitely give me the addition of the vector. Now from here I can write the magnitude of this addition vector, addition of these two vectors can be represented as, the magnitude will be represented as a square, the magnitude of vector a ka whole square plus magnitude of b ka whole square plus 2 times of a ka magnitude into b ka magnitude into cos of theta. Now if you calculate this particular expression, this expression will give the length of this diagonal. This particular expression will give the length of this particular diagonal. So I hope this particular condition comes very helpful. Now if I say that this is a plus b vector and this a plus b vector makes an angle phi with the a vector, now this particular angle can also be represented in terms of tan of phi is basically equal to b vector ka magnitude in times of sin theta divided by a vector ka magnitude plus b vector ka magnitude times of cos of theta. Now this result is very simple to memorize. From here what we see that the angle term is actually involved with b vector. The angle term is actually involved with b vector, and if you remember in the fashion, the sin theta comes above and cos theta comes below, such that sin theta by cos theta is actually tan theta. So you can represent this term, you can memorize this particular result. इस चीज़ को ऐसे याद रख सकते हैं कि ऊपर में sin theta आएगा, नीचे में cos theta आएगा, क्योंकि tan theta is basically sin theta upon cos theta, and b के साथ हमेशा एंगल आता है, तो b times of sin theta divided by a का modulus plus b का modulus times of cos theta. So I hope this particular result, it comes very handy. Now if you want to know about the derivation of this particular result, stay tuned for this upcoming lectures where I will take up the concept of component of vectors, and when I will talk about dot product and or the scalar product, then I will take up the explanation of the derivation of this particular concept. So with this, let us get and try to solve an important question which is actually based on the JEE Mains previous year questions, and actually which is based on the vector addition. So from here you can sense that how easy question actually comes up in the exam on vector addition or the topic of vectors. The topic of vectors is very simple. if you study it nicely and understand it with lots of examples and understand with help of diagrams also. Okay, so with this, let's start this question. So what the question says, that there are three vectors such that the magnitude of the vectors are basically equal to unity, that is basically they are unit vectors. So what I can say for the unit vector, that all of their magnitude are equal to 1. We studied in the types of vector, and what is given in the question, it says that you have to comment on this particular magnitude, that a minus b का vector का whole square plus b minus c vector का magnitude का whole square plus c minus a vector का magnitude का whole square. Now similar to this, let me talk and say that if I have subtraction of vector, a subtraction of vector is not a difficult case. Okay, the subtraction is basically subtracting is basically adding the negation of this particular vector. Okay, subtraction is basically adding the negative of this particular vector. So if I can add this particular vector with the negative, so and I can represent the magnitude, then this particular magnitude doesn't changes from this particular result, only there comes a negative sign that you have to take care of. So you have to take care, in this particular case there will be negative sign introduced in this case. Okay, that is a vector का modulus and b vector का modulus multiplied by cos theta. So from here what we see, that there is a negative sign which is involved in this particular case. There is a negative sign which is actually involved in this particular case. Now let us try and solve out this question. Now what is given in this particular question, and this particular quantity, if I represent this quantity as d quantity, so this d, this is actually modulus terms and modulus terms, which is a scalar quantity, so I represent d. So if I expand this particular quantity, so I can write this as also as a vector का modulus का whole square plus b vector का modulus का whole square minus 2 times of a vector dot of b vector. Okay, now these results comes from basically from the expansion of two numbers. So if I say a plus b का whole square, you can say me as a square plus b square plus 2 times of a into b. In a into b is basically actually represented as times of dot product. Now if you don't understand this particular thing, stay tuned for the upcoming lectures. But if you actually expand this particular result, results comes out as this particular fashion. Similarly you can write this also as b square plus c का modulus का whole square minus of 2 times of b into c. And similarly the third thing can also be written as c का modulus का whole square, a का modulus का whole square minus of 2 times of c into a. Now from here if I solve the result, I will get 2 times of a का modulus का whole square plus b का modulus का whole square plus c का modulus का whole square minus of 2 times of a dot b plus b dot c plus c dot a. Now from here if I see that all the modulus values are equal to 1, and if I see this result, the result comes out as 6 into that is 2 into 3, that is 6 minus of, and if I write this particular thing, that is a into b plus b into c plus c into a in vector quantities, can also be represented as, can also be taken as and represented as this particular a plus b plus c का vector का whole square minus of a का modulus का whole square plus b का modulus का whole square plus c का modulus का whole square. I hope this particular thing is clear from the result, that we already know that a plus b plus c का whole cube, a plus b plus c का whole square is basically equal to a square plus b square plus 2 times of ab plus bc plus ca. Okay, so from here if you represent in terms of vectors, these vectors also comes out as these results. Now this result will actually study in the topic of scalar product. This result we also will study in the topic of scalar product. So for now you can skip this question if you don't understand the topic of scalar product, but if you understand the scalar product, then you can proceed with this question, and you can write this question from here. You can write this particular terms as, now a plus b plus c vectors is actually unknown. This particular quantity का modulus, that means square, is actually represent the modulus of the square, that this quantity is unknown. So from what I can see, say from here, this particular quantity will again result in 3. So from here I can write this quantity as 9 minus of some square quantity, 9 minus of some square quantity. Okay, so this result can also be written as 9 minus of some square quantity, that is a plus b plus c का whole square. Now this particular result will always be less than or equal to 9, because we know that any particular value of a square will always be greater than or equal to 0. So from here if I subtract a square quantity from a 9, then this particular result will always be less than or equal to 9. So from here the question says it does not exceed, that is the maximum value of this particular expression can only be what, that is 9. So this question was actually taken up in JEE mains. So with this you can sense that how easy the question is. If you understand the concepts well and you can apply the concept and you get the result very easily. So you don't have to memorize a lot of results or formulas, just you have to understand the concept and that's it. Okay, now let us take up another important topic, that is vector addition. Now before starting with the topic of vector addition, we will take up in this particular question. Now let me take up and understand that if there is a vector which is actually represented in times of a component of another vector, that is I cap, j cap and k cap. Now these particular things are basically equal to mutually perpendicular vectors. These are basically mutually perpendicular vectors, and the unit vector along this mutually perpendicular vector, for example, if I have x, y and z axis, they are basically mutually perpendicular vectors. They can be represented as mutually perpendicular vectors, and if the unit vector along the x axis is represented as I vector and the unit vector along the y cap is represented by j vector and the unit vector along the z axis is represented by k vector. So this particular is very is the important nomenclature which we will also study again when we study about the topic of components of vectors. So before starting this particular topic of component of vector, I took up the question to show you that the component of vector is nothing but the vector addition can also be implied in terms, the question can also will coming up in terms of component of vectors. Now in that particular case, you just have to add up the individual component of the two vectors. The individual component of the two vectors get added. I took up this question just to explain you that a vector's the magnitude or direction का कैसे निकाला जाता है. So let me get and start with the question. I hope this particular important discussion was clear, that you take out the individual component of the vectors and add the individual respective corresponding component. For example, the I cap component of the A vector, if I say the A vector plus B vector, then the I vector component of the A vector and the B vector I vector component of the B cap component of B vector will get added to the I cap component of A vector, and similarly the J cap component of the A vector will get added to the J cap component of the B vector. So let me solve and get to the result. So if I see from here, if I calculate A vector plus B vector from the discussion that the individual component get added, then I can say this is 4 plus 6, that is 10 of I cap plus of, that is 8 minus 3, and basically will be 5 times of j cap. Now from here, if I get the vector like this particular fashion, then I can write the vector. If I have this particular vector basically addition of two vectors. So if I write this particular small a vector and this particular vector as small b vector, I can write this magnitude of this vector, that is capital A plus capital B magnitude can also be written as magnitude of small a vector plus magnitude of small b vector. Now what I can write this magnitude of a small a vector and small b vector, and we also know a result, an important result that we will also study in the topic of scalar product, that is I cap dot j cap is basically equal to 0. Now from using this particular result, if I add this particular vector, that is basically 100 cos square plus 25 cos square, that is 25 plus 2 times of 10 into 5 into cos of theta. If I eliminate this cos theta, now basically if I see cos theta, so what will I say? Now the two vectors are basically mutually perpendicular, so this cos theta is basically cos of 90, that comes out to 0. So if I calculate this expression, this is root of 125. From here I get the magnitude of a plus b vector is basically equal to 5 root 5. And if I want to know what is the direction that the a plus b vector makes with the direction of the a vector, or if the question mentions that you have to take the direction in such fashion that is in the xy plane, what direction does it make? That is the direction with the I cap, the direction with the I cap. So in that particular situation, if I want to know about the direction that this particular vector makes with the I cap, the only result that we have to apply is basically dot product. But we already studied about an important product. If I say from here, now if I take up this particular thing in this particular fashion, for example, a vector and b vector is given in this particular plane, and the summation of this particular vector is basically, this is actually a plus b vector. Now if I want to know the angle which this vector actually makes with this a vector, if I want to know from the, there's a question actually says the angle that the addition vector makes with the x-axis, but if I want to know the angle this a vector makes with the a plus b vector, then I can directly apply the result of tan alpha is equal to b ka modulus times of sin theta divided by a ka modulus plus b ka modulus times of cos theta. Now if I want to know the angle which it makes with the I vector, we have to apply the results of dot product. So for the students who doesn't know the dot product, you can skip the question for now, and you can also try the question once you understand the concept of dot product. So if I take up the dot product concept, that is a cost, if I want to know what is the value of cos theta 1, that is the angle which the a plus b vector makes with the x-axis, I basically have to take the dot product of this particular vector with the I vector and divided by the modulus of both the vectors. and we know that these are basically unit vectors, which is modulus 1. So from here what I will get, the modulus, the a plus b vector is basically equal to 10 I cap plus 5 j cap divided by what the result is, sorry, and actually into I cap divided by 5 root 5. So from here if you compute the dot product, you will get the result as 10 divided by 5 root 5. So from here if you cancel this particular results, you will get the result as cos theta, the theta value, that the angle, that is theta 1, will be equal to cos inverse of 2 by root 5. But the question talks about in terms of tan inverse. So this category result can also be represented as tan inverse of, this is based by hypotenuse, so I can write this as base over here, and if I see the perpendicular, this is basically 1, so I can write this as tan inverse of 1 by 2. So from here I get the correct answer to this question is basically option number B. So I hope this discussion was clear. Okay, so with this let us move on to the another important topic on the algebra of vectors, is basically the subtraction of vector. Now I already explained the subtraction of vector is basically nothing but adding the negation of this particular vector. So if two vectors are subtracted, that means this is basically equal to adding a vector with the negative of that particular vector. So in this case what we can do, if I say the vector is A and this particular vector is B, and I complete the parallelogram in this particular fashion, if I complete the parallelogram in this particular fashion such that one of the diagonal actually represent by parallelogram law actually represent the vector addition, and by C, if we want to see that this particular diagonal which is in the direction, so if I represent this particular points as OA, B and C, and want to know the vector which is in the direction of C to A, that is CA vector, now basically the CA vector will basically represent what? So from here if I want to, if I change this B vector and write in terms of negation, then the direction will be this particular fashion. Now if I join the head with the tail of another vector and then I join the tail with the head of the vector, then we get the what is called the vector addition by triangular law. So from here what I see, I get the addition, that is A vector plus addition of minus of B vector. So this particular vector which is along CA vector, that is a CA vector, will basically represent A vector minus of B vector by the simple law of triangular law of addition. So similar to this particular result, the results of this vector subtraction also similar. So the A vector minus B vector modulus can be represented as A vector का modulus का whole square plus B vector का modulus का whole square minus times of A vector का modulus times B vector का modulus times of cos theta. So I hope this particular result will come very handy in calculation. Now we already saw a question regarding that particular situation. Now let us move on and try to solve another important topic, that question that actually came up in JEE Mains 2023. Now if I see this question, now what does question mention? That there is a vector which is A vector which is represented in times of 2I cap plus 3j cap plus 2 times of k cap. Now if you are not able to understand what is this I cap, j cap and k cap, now I want to clear it out very clearly. So when I will be talking about component of vector, this particular concept will seem very clear. But if I want to talk about for the question, for the purpose of the question, if I say there is a vector which is in the xy plane, this vector is A and B vector. So if I see and this angle is theta, so I can do one thing. If I can take this component, if the projection of this particular vector on the x-axis, if this projection is known as A parallel, and I can write this projection as A cos theta. And similarly if I take the projection on the y axis, and I can say the projection as A perpendicular as A of sin theta, then this particular vector can also be represented as A cos theta times of I cap plus B A sin theta times of j cap. Now how I can write this particular thing? Now I can do one thing, that this particular vector is actually the addition of this vector and this vector, and let me write these vectors as small OA vector and OB vector. Now A vector by the parallelogram law of addition can be written as summation of OA vector and OB vector. Now from here if I represent OA vector by magnitude and direction, that is A cos theta times of I cap, if I say the unit vector which is associated with the x axis is I cap and the unit vector which is associated with y axis is actually j cap, then I can write this particular vector OA vector as A cos theta I cap and OB vector as A sin theta j cap. Now in this particular fashion also a vector can be represented, and this particular topic will be basically clear when we study about the component of vector, which is in the upcoming classes. Okay, now let us solve the question. Now what does question mention? The question actually mention that there is a vector which is A vector and is represented 2I cap plus 3j cap plus 2k cap, and it is subtracted from a vector that is B. That means it is subtracted from vector the B. So B minus A is actually gives a vector which is equal to 2j cap. So there is a vector b, and if it is subtracted from a vector, then it gives the result as 2j cap. So from here I see one important thing, that is a vector minus b vector का modulus जो है ना वो उसका value 2. Okay, now I have to comment on the modulus, the magnitude of the vector b. So before so if we try to solve this question in a simple fashion, such that if I want to solve this question and see the result, okay, the question that is b minus a vector का जो value आने वाला, that is 2j cap. Now from here I can write the vector b as basically a vector plus times of 2 times of j cap. So from here what I get the result as 2I cap plus 5j cap plus 2 times of k cap. Now from here I can write the magnitude of b vector as, if I square and add the vectors, add the individual components of this xy and z axis components, and then I square and add and take the square root, then I basically get the magnitude of these vectors. So how we are getting this vector magnitude, also if I want to talk about this particular concept will also be clear when I will talk about the basically about the topic of component of vector. Okay, before topic of the component, if I say and the magnitude of this particular vector can also be written as a का cos theta का whole square plus a का sin theta का whole square. Now from here we know that cos square theta plus sin square theta basically gives the result 1, and this particular result comes out as a. So if I say that the length of this particular arrow is a, then a का modulus becomes a. So from here what I see, that it is equivalent to square the magnitude of this OA vector and add it with the square of the magnitude of OB vector, and they take the addition and then finally take the square root, then basically we get the result which is known as the magnitude of this particular vector. So similar to this particular concept, when any vector is actually represented in terms of 3 mutually perpendicular vector, when any vector is represented in terms of 3 mutually perpendicular vector, its magnitude actually is given by squaring the individual component and adding it and then taking the square root, then we get the magnitude of the vector. That this result comes very handy, and I will discuss upon this result on much important details when I study about the dot product. Now in many situations I already talked about this particular concept is related with this particular thing and this particular, actually the chapter is like this only. So you have to study the whole chapter, and then if you try to solve the question will be very simple. But if you have a good understanding with understanding the question as well as taking on the concept that I am explaining to you, then the chapter will also be simple in my terms. Okay, so with this, if I calculate compute the result of b magnitude, then I get 4 plus 5 cos of the 25 plus 4. So from here I get the result, that is basically 25 plus 8, that is basically root under 33. So from this I see the answer to the question. Is basically option number B. I hope this particular question was simple and clear. Now this is a very simple question. It is very simple question that actually comes up in the topic of JEE mains examination. Now let us move on and study further about on the algebra of the vectors. Now multiplication of vector by a scalar. Now we will study about the multiplication of two vectors, that is scalar product and vector product, in upcoming videos. But multiplication of vector by a scalar actually means, for example, there is a vector which is a and it is multiplied with a scalar. This is actually a scalar quantity. That means basically it adds a value to the modulus, the magnitude of the vector. The magnitude of the vector changes by the unit times or alpha times of that particular modulus, but the direction remains the same. So if I say there is a vector which is a vector directed in this particular fashion, and if I want to know what is the value of 2a vector, then I will do nothing but I will, in the same vector, I will extend this particular length in this particular fashion such that the magnitude becomes 2 times of modulus of a. 2 times of modulus of a in this particular thing. So if I say this is the modulus of a, now if I represent this new vector by 2 times the modulus of the a, then such vector which magnitude changes by that particular amount, that is alpha times that particular vector, then such particular concept is actually known as the multiplication of vector. The direction remains the same. Direction is same. So okay, the magnitude get changed by alpha times the magnitude of a. So only the magnitude changes by alpha times the magnitude of a, but the direction remains the same. So this particular topic is very important topic of multiplication of vector. So similar to multiplication, we already studied about unit vector, that is basically multiplying 1 by modulus of a to this a vector which is a vector. So this is particular thing is also a multiplication of a scalar quantity, and 1 by modulus of a is basically a scalar, and if you multiply the scalar to this particular vector, that is a, then we get the vector result which is known as a unit vector. So I hope this particular concept is clear. Okay. So with this we come to the end of this particular lecture. Okay, so I hope this important topics was actually covered in nice details. Okay, now before coming to the end, okay, I wanted to also discuss upon some properties of vectors, multiplication of vectors. Okay, now basically if you see multiplication of vectors by a multiplication of a vector by a scalar also for the same properties which a real number follows. So if I take another vector and multiply with it, is basically same. If I have this particular negative of this vector and I multiply a scalar, this particular thing is same as multiply the negative of the scalar to this vector A. Similar to this result, I can also write an important result, that is basically m into A plus B vector can also be written as m times of A vector plus m times of B vector. Now this property is basically known as the distributive property. Okay. So this particular vector property, similarly to the property, there is another property. If I have another scalar, that is m plus n, and added to and multiplied to A vector, then this can be written as m times of A vector plus n times of A vector. So I hope these particular results are handy, and you will remember these particular properties in nice detail. So in the upcoming lectures we will see basically the understanding of these particular concepts in wonder details. Okay, so with this I come to the end of the lecture, and in this today's lecture was a basic introductory to the concept of vectors. I hope that you understood all the important concepts of vectors, and you will appreciate my content. So if you like this particular videos, okay, and then definitely check out the playlist of vectors, as well as check out the if you are not following the all the content in the curriculum manner, then what I am teaching on. So firstly I already took up the playlist of matrix indeterminate. So always follow the matrix indeterminate particular playlist, and then come up to the vectors and 3D geometry to have a good understanding. So I hope you will follow all the lectures in a given sequence as I am uploading the lectures. Okay, so with this I come to the end of the lecture. And if you like this particular lecture, don't forget to like the lecture as well as subscribe to my channel. So with this I come to the end,